So far what I've been doing is to adjust our controller based on all this U and X inputting into the controller so that the controller will output a certain stuff. Alright, this is for the open loop system. Alright, to adjust the controller's input, which is X. Alright, we can also have an output, we can also have a closed loop system that can output something into the controller, or input something into the controller, if you were to say. Okay, these are all talking about controllers. We are only somewhat fine-tuning our controller to our specific demands. Alright, but in a more close larger point of view, if you still remember, this is the CP over 1 plus CP. If you still remember, this is the very classical form of our transfer function, right, that incorporates controller and the plant all together. Alright, for our case right now, all we've been doing, alright, all along is to only fine-tune the controller. Okay, we did not fine-tune what is actually the controller's output, which is Y. Alright, we're only talking about how to pole assignment the pole for the controller so that we can shift our controller's output to whatever values that we want. But the output that we want has to reference with something, right? Reference with something that we want. And therefore, we are going to talk about a reference signal coming into the controller. Okay? So in some sense, we are talking only about this portion over here. Alright? Let away the feedback from the plant also. Okay? So we are not talking about the plant at all. Alright, so we are only focusing on this section. Alright, so a reference signal got to input into your controller. Okay? So for an open loop system, it's pretty much straightforward. Alright, you just input a reference signal from behind. Alright, but there's no point because you didn't have any feedback to adjust your this part over here. So in order to adjust, alright, we need a feedback system. So therefore, we're often focusing on the feedback system now. Alright, and how does the reference signal work? We're going to input a reference signal that is a steady state, alright, a constant. We're going to input into our system over here. And we got also input a certain reference signal to reference and adjust our feedback that is coming from here. Alright, so we're going to we have a 2-point reference signal. Alright, and in order to adjust the value of U, alright, and in order to adjust the feedback system of minus kx over here, so U at first was minus kx, so in order to adjust U and minus kx all together at one shot, alright, our reference signal is gonna require certain multiplication, say NU. So when you multiply your reference signal and somehow adjust your system over here, eventually you output Y such that it is equals to your reference signal. Alright, later on we'll talk about it, but anyway, so you also have some other constant factor of multiplying over here, okay, so that you can adjust your feedback also. So you adjust your U using NU, and you adjust your feedback also using NX also. Alright, but in any of the case, alright, this whole thing over here, the purpose is to adjust your output equals your reference signal. Okay, your output has to be equals to your reference signal, and this portion over here is to adjust such that your output is equals to your reference signal. Alright, so therefore if there is no adjustment, alright, where adjustment is equals to 0, this means that your x dot over here is equals to 0 because there is no adjustment anymore. Alright, and therefore reference signal is always equals to your output over here. Okay, and therefore your AX is equals to your BU. Alright, maybe I should say that your AX is equals to minus BU. Okay, so to speak lah. Okay, where your U, you know it's minus KX, if you remember coming from here. And it's all the very complicated stuff, but just to let you know that adjustment, eventually you want it to be equals to 0, so that you will not adjust anything, and that your reference signal will therefore be your output. And this portion over here is to adjust your whatever stuff. Okay, and therefore your x dot ss is equals to 0. Your adjustment is equals to 0, which is shown in your PPT, your presentation slides. Alright, and this AXSS plus BUSS comes from your typical state space system. It's just simply adding your steady state only, so that it looks like this all along. Okay, as you can see, it's the same as this. Same thing for the bottom one. If you want to write SS, SS all the way SS, alright, it's the same thing. Okay, but for steady state system, these are all reference steady state. Therefore, your everything over here is talking about when your adjustment over here is equals to 0. Alright, so when your adjustment over here is equals to 0, everything is steady state because nothing changes at all. Alright, I hope this is pretty clear so far. And since there's nothing changes at all, x.ss is simply equals to 0 as we have said, and therefore your output is equals to your reference signal. Alright, which is pretty clear. Okay, and instead we will write my XSS, alright, as NRSS, my USS as my NURSS, okay, which is over here. NURSS is for this thing over here, alright, NXRSS because it's going in this manner, alright, so therefore you have your AXSS over here. Okay, I hope that this is pretty so far clear. So we just simply rewrite our XSS is equals to this thing. That's all. This is your input into the controller. This is your feedback system from your adjustment. So this is the feedback from adjustment. This is your input, where your x dot over here we're gonna become this, and this thing is your input into the controller. While your u over here tells you the feedback from your x all the way here. Alright, including plus with adjustment from here lah. Okay, in this case. So I hope that this is so far clear also. Therefore, in order to formulate a correct nx and nu value, alright, we're gonna write in terms of a matrix. Alright, where your A, B, C, and D are all placed over here. Okay, your n, because for example, because your NXRSS, or A times NXRS plus B times NURS, these are all having RSS, so therefore they can just cancel each other. Alright, same thing over here, we can cancel each other because RS is simply the same constants. Alright, so therefore I have ANX plus BNU. Alright, ANX plus BNU, which is A times NX plus B times NU, which is the first row. Alright, which is equals to 0 because the adjustment is equals to 0 already. Alright, your C plus D, alright, your CNX plus DNU, which is this one, is equals to 1, or one reference signal if you're so to speak. Alright, because your this system over here, CX plus this thing over here is equals to your reference signal, is equals to your output steady state, so to speak. Alright, so you can rewrite everything in this form, and then we inverse this matrix such that this matrix over here, if you were to inverse, the solution for your systems will be this thing. Alright, we will not go into the example, but this just to prove to you these things. Alright, therefore if you have any value of A, B, C, and D, you can easily formulate your NX and NU, and then you can simply sub it into your systems over here, such that you eventually acquire your steady state as a whole. So as you can see, this is a foolproof solution to help you acquire your steady state. Your RSS is equals to your Y. Alright, your reference signal is equals to your output. And therefore, this is the purpose of me doing this video, is to sum up, give you a full iteration of how this full closed loop system with regards to your reference signal, ensuring the reference signal is equals to your output eventually, okay, using all the steps. So in the next video, we will somewhat derive using what we have learned to have this thing over here. Alright, somehow we want to combine this whole chunk over here, all this thing over here, as simply this thing, so that it looks nicer or something like that. I don't know. Not I don't know, but rather than, because it's in the form of like you know, AX plus BU type of form. You remember the state space system, the very typical one. So you often want to write our systems in terms of AX plus BU. Okay, so in order to do that, in the next video we'll discuss. But I hope that this video is pretty clear to illustrate to you how to find NU and NEX and all these things. Alright, see you in the next video.